All right, here are the video notes for lesson 3.2, logarithmic functions and their graphs. First thing to note before we get going, we need to know that the logarithmic functions are inverses of the exponential functions and that we're going to use exponential functions to help us graph these logarithms. So looking at the first example, we have the logarithm log base 2 of x, and then we have the exponential form of that, which is 2 to the x, okay, based on this rule in this slide here, okay? So we need to do an xy table for both, which looks like 2 to the x, xy table. You have -2, -1, 0, 1, and 2. This gives me 1 over 4. This gives me 1/2, 1, 2, and 4. And then since this log function is just the inverse of that, we just flip the x's and the y's. And this is how we're going to graph every log function, okay? So my x's become 1/4, 1/2, 1, 2, and 4, and my y's become -2, -1, 0, 1, and 2. And then I use this xy table to graph the function. And with these ones with like 1/4, you just do your best to plot it correctly. So we go over 1/4 down 2. So you start down here, and we get a function that looks something like this. I believe that I script that one. It should be 2, 1. I believe I have that. 2, 1, and then what is it? 4, 2. Something here, and then you have your logarithmic function being formed. Okay, and it is, if you look at this picture down here, it is just the inverse. So this one here on top, that's going to be my exponential. This inverse here is going to be my logarithmic. Okay. Now there's another example like that, but I want to skip ahead to one that's a little bit different, and it's this one here, because this one, instead of just being 2 steps where we flip the x and y, we have a third step added. Okay, so this is negative log base 3 of x plus 2. So the first thing we need to do, we need to start with graph or xy table for 3 to the x. So xy table here, -2, -1, 0, 1, and 2. This gives me 1/9, 1/3, 1, 3, 9. Then we go to log base 3, so we're not even at the final product yet, but we go to log base 3 of x and we flip it. So my xy table gets flipped. 1/9, 1/3, 1, 3, 9, -2, -1, 0, 1, and 2. And then we add in the transformations. And so we have negative log base 3 of x plus 2. And these transformations here are performed on our y's. Now, there are situations, and we'll see when we get to natural log, where they get transformations performed to x. But because the negative is outside, not in the parentheses, and because the plus 2 is outside, not in the parentheses, that parentheses don't exist here, of course, but they could, but they don't, is that the plus 2 is going to make our graph go up 2, and the negative is going to make all of our y values being multiplied by -1. And so our x values haven't been changed, so they're 1/9, 1/3, 1, 3, 9. And then, like I said, we have to multiply all our y's by -1 and then add 2. So -2 times -1, that's +2. Add 2, that's 4. -1 times -1, that's +1. Add 2, that's 3. 0 times -1 doesn't matter. It's still 0 plus 2, that's 2. And the pattern continues, and so you get 4, 3, 2, 1, 0. And then we graph what's in this table. And so if I go there, I got to go over 1/9 up 4. And then I got to go over 1/3 up 3. And then 1, 2, 3, 1, and then 9, 0 here, and I have my logarithmic function right there. And you can see how the transformations took place. Okay? Now, one of the big ones here, I don't want to skip over it, is this function here, this way that we can rewrite logs as exponentials and how we can write exponentials as logs. So log base 3 of 9 equals 2 gets rewritten as 9 equals 3 to the second power. On the other hand, 5 5 to the third power equals 25, that's log base 5 of 125 equals 3. And to see an example of this, this would be like, well, base 4 equals 2, so that's 4 squared equals 16. Base 9, negative 2, that's 9, negative 2 equals 1 over 81. Other way around, we have log base 5 of 125 equals 3, or log base 81 of 3 equals 1/4. Okay, so we can use that relationship to help us out. We have a bunch of examples here, and what I'll do is y equals log base 2 of 32. And what you'll do is, well, it's log base 2y, so that's 2y equals 32 using that relationship. And I say, what y value what 2 raised to what gives me 32? And that would be y equaling to 5. The other way you can do it from lesson 3.1 is get the same base here. So this could be, the same thing could be, 2 raised to the y equals 2 to the 5th power. And since the 2's are the same, you're allowed to put the exponents equal, and so y would equal 5. Two different ways to see it. Okay, same kind of thing here. You have y equals log base 3, and I do change it to y. It helps me see it. Of 1, this becomes 3 to the y equals 1. Well, I know y must equal 0 because 0, raising anything to the 0 power equals 1. Okay, a bunch of examples, but I'm going to skip ahead so I can stay in my time limit here. When you see a function that is just log, so if it's like log of 10, that's secretly the log base 10. Okay, so log base 10 is just simply denoted as log, and that comes into handy here. Some big ones that you need to take notes on, all these properties of logarithms, and we'll practice a little bit here. Okay, so we have, following the first one, the log base anything to the first equals 0. So log base 4 to the 1, well, that's going to equal 0. Using the second one, log base a number to that number, so log base a of a, and that's what I have here, log base square root of 7 of square root of 7, that's always going to equal 1. Okay? We also have these ones here, where we have 6 log base 6. It's pretty much like they cancel, and this is just going to equal 20. Here, since we have the same logs, log base 3 equals log base 3, we just set these equal to each other, so x and 12 get set equal, and so x equals 12. Here, again, this is log base 10, so we set them equal to each other, 2x plus 1 equals 3x, and we solve for x. Same kind of thing for the rest of them, is just using that one-to-one relationship. Here, we have a little bit different. This cancels with this, and so we have 81 equals x to the 4th. You could you could do the 4th root of this, and the 4th root of 81 would give me 3. Another way you could see the 4th root is square rooting something twice. So the square root of 81 is 9. Square root again, you get 3 equals x. The next thing is natural logarithms, and they work the same as logarithms. And another way to say ln of x is log base e of x. And so e is that natural number that we looked at. Excuse me. Sorry. Log base e of x is the same thing as ln of x, and we do pretty much a very similar thing with it. Okay, and so looking at one, we have this, and we'll do e to the x. We'll do the xy table for that one first. And so -2, -1, 0, 1, and 2. And grabbing my calculator because I can't do this without it, because e is a very funny thing. You have e raised to the -2. That's going to give me 0.13. To the -1, that gives me 0.37. Anything raised to 0 is 1. Just e is 2.72. And then e raised to the second power is 7.38. That means ln of x is just the flip of that. So xy, we flip our xy values. We have 0.13, we have 0.37, we have 1, 2.72, 7.38, and then our y's become -2, -1, 0, 1, and 2. And now we just need to add that shift here. Well, just like it was with quadratics, if it's inside the parentheses, Okay, this is going to be a shift left or right, and because it's a negative, we're shifting to the right. Okay, which means really we're going to add 4 to all of our x values because we're shifting our graph to the right 4. So the ln of x minus 4, I'm adding 4 to each one, so my xy table looks like 4.13, 4.37, 5, 7.72, and then 11.38. Sorry, 12.38. 12.38. Okay, and then my y's stay the same. There's no shifts happening to the y's, so -2, -1, 0, 1, and 2. And then I graph my xy table in the final one there. Okay. Now, to keep moving, we will look at writing these as exponential functions. Like I said, can be seen as the log base e of 1/2 equals -0.693. And so if that's e and this is there, so this becomes e raised to the -0.693. It's a 0. That's going to equal 1/2, just rewriting it. And then here we have the log base e of 1.6487, and that's going to equal 1/2. So just different ways to write it, still following the logarithms rules. Or another way to write it, instead of using log base e, you could have said ln of 1.6487 equals 1/2. Okay, you can see these properties of the natural log are the same as the properties of the logarithms, except for we use e. And so to see some of those, we have this here. This would be the same thing as ln of e to the -1. And since it's ln and e, this just becomes -1. That's using this rule here. ln of e to the x equals x. Well, in this case, ln of e to the -1, my x is -1, so it equals that -1. ln e to the ln of 5, that's going to follow this rule here, where e raised to the ln is just going to equal x, so this is equal to 5. Here we have ln of 1. Well, ln of 1 equals 0, and so this becomes 0 over 3, which equals 0. And then last one, we have ln of e to the first power, which is going to give me 2 times 1, because the ln of e is equal to 1, which equals 2. Again, just using the properties of those natural logs. Here is the homework, updated homework here at the end. Only these, don't worry about these ones up here. Don't worry about this up here. Just these 5 problems for homework in this lesson. Okay? And then lastly, quick look at next week. We have the lookout for the week. So Tuesday is this lesson, practice quiz, and then no work. And then we have a quiz in lesson 3-4 on next Friday. I went through this one quickly to stay in my time frame. If you want to see any problem, or if you're going through those written notes and have any questions, just email me and I'll make individual videos.